Welcome to another tutor short provided by the Educational Support Services Department at Lehigh Carbon Community College in Schnecksville, PA, just outside Allentown. These videos cover key concepts for math and other math-based courses here at L-Tri-C. Please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week in math and other subjects. This tutor short video is Solving Linear Equations Part 1. We will cover how to solve one and two-step equations. When you are solving an equation, you are working with inverse operations. Every operation in math has an inverse operation. That is, there is some way to undo everything that you can do. The way to undo adding is to subtract. So then to undo subtracting, you add. Adding and subtracting are inverse operations. They undo each other. To undo multiplying, you divide. So to undo dividing, you multiply. If we look at our order of operations, we can see that these inverse operations are next to each other. Adding and subtracting. When we talk about order of operations, we know that adding and subtracting are the same priority. You do them from left to right. That's because they can undo each other. That's why they're grouped together. The same is true for multiplying and dividing. When we are solving equations, instead of working through PEMDAS in the normal fashion, starting with parentheses, exponents, multiply, divide, add, subtract, now we're going to be working backwards. We're going to undo adding and subtracting first, then we're going to undo multiplying and dividing. So here we have some one-step equations. Our first equation is x plus 8 equals 16. In this problem I'm adding, so to undo adding, I subtract 8 from both sides. These are going to cancel out because positive 8 minus 8 is 0. I'm left with x equals 8. If I plug my answer back into the original problem, 8 plus 8 equals 16. That's correct. So this is my answer. Our second example is x minus 9 equals 2. This time I'm subtracting 9. To undo subtracting 9, I'm going to add 9 to both sides of my equation. That is, once on each side of the equal sign. Negative 9 plus 9, those cancel. I get x equals 11. 11 minus 9 equals 2. That is true. So that is my answer. Next we have 3 times x equals 12. I'm multiplying, so to undo that I need to divide. I'm going to divide both sides by 3. My 3's are going to cancel. X equals 12 divided by 3 is 4. 3 times 4 equals 12. That works. I have my answer. Next we have x divided by 4 equals 8. To undo dividing, I'm going to multiply. I'm going to multiply both sides by 4. Here you can write just 4 times x over 4, or if you want it, you could put this over 1. Then you'd get 4x over 4. 4's cancel. 8 times 4 is 32, so x is 32. If I check that, 32 divided by 4 equals 8. That works. I have my answer. Our last example of one step is 3x divided by 2 equals 10. Now in one way this looks like it is 2 steps because I have 3 times x and divide it by 2. I have to undo my multiplying and undo my dividing. However, I can rewrite this as 3 halves x equals 10. Now to get rid of multiplying by 3 halves, I'm going to multiply both sides by 2/3. To multiply my fractions, I can put my 10 over 1. That way I still have a numerator and denominator. On the left side of my equation, my 2's are going to cancel. My 3's are going to cancel. I'm left with x equals 10 times 2 is 20 over 1 times 3 is 3. So my answer is x equals 20/3. If I plug that back in, I'd have 3 over 2 times 20 over 3 equals 10. My 3's cancel. 20 divided by 2 is 10. That does work. Two-step equations. First, I have 2x plus 3 equals 9. So we said we have to do order of operations, or PEMDAS, backwards. I'm going to start by undoing my adding. So I'm going to subtract 3 from both sides. So now I have 2x equals 9 minus 3 is 6. Now I have 2 times x, so I'm going to divide by 2 on both sides. X equals 3. And I can check that 2 times 3 plus 3 equals 9. 2 times 3 is 6 plus 3 equals 9. 9 equals 9. That worked. This is, in fact, my answer. It's always a good idea to check your answer and make sure that it does work. Next we have 1/2 times x minus 4 equals 7. Again, I'm going to start by undoing my subtraction, because I'm doing PEMDAS backwards. So to undo subtracting 4, I add 4. Those are going to cancel. I have 1/2 x equals 11. I have 1/2 times x equals 11. Normally to undo multiplying we'd say divide. I don't really want to divide by a fraction. When you have a fraction, you work with reciprocals like we did with 3/2 on the last slide. To undo multiplying by 1/2, I multiply by 2 over 1. And I can put my 11 over 1 as well. 2's cancel, 1's cancel. X equals 11 times 2 is 22. 1 times 1 is 1. 22 divided by 1 is 22. So let's check this. 1/2 times 22 minus 4 equals 7. 1/2 of 22 is 11 minus 4 equals 7. 7 equals 7. Yes. There is my answer. Our next example is 10 minus x equals 5. So there are 2 ways we can go about this. Since we have minus x, I could add that to the other side. Or I can, since this is a positive 10, I can subtract 10 from both sides. Here these cancel. I'm left with negative x equals 5 minus 10 is negative 5. So now, right now I have negative x. There is an invisible 1 in here. So it's really negative 1 times x equals negative 5. So I'm going to divide both sides by negative 1. So x equals 5. Plug this back in to check. 10 minus 5 equals 5. Yes, 5 equals 5. When you're doing a problem like this, don't lose track of that negative sign. Because you could also consider this as being 10 plus a negative x instead of 10 minus x. Our last example, 7 plus 2/3 x equals 3. Again, start by undoing my adding, so I'm going to subtract 7 from both sides. And I get 2/3 x equals 3 minus 7 is -4. Now 2/3 x equals -4. To undo multiplying by 2/3, I'm going to multiply both sides by 3/2. And I'll put my -4 over 1. 3's cancels, 2's cancel. X equals -4 times 3 is -12. 1 times 2 is 2. -12 divided by 2 is -6. I can check this. 7 plus 2/3 times -6 equals 3. 7 plus 2/3 times -6 is going to be a -4. 7 plus a -4 is 3. 3 equals 3. This is, in fact, my answer.